Hi, I'm Zach Weaver, Creative Technologist at Building 61, the Boulder Library Makerspace. Today, we're talking about modeling for 3D printing.
Okay, let's get started with something very simple like a cube. A cube has 1, 2, 3, 4 sides. It also has a top, and importantly, it also has a bottom. Now, for some 3D modeling programs, when we're designing for an animation or a video game, we might not care that that bottom plane is actually represented in our image. 3D printers, however, will look at that image and they will look for a bottom plane. If we didn't have all 6 sides of that box represented, what we might see is something like this. And now the 3D printer doesn't know what to do in this bottom window. So it's important that we represent all sides of every object and that their edges are perfectly joined, or what we call airtight. Well, now you might be thinking, Zach, can we print open shapes like an open box instead of a big, chunky, solid thing? Yeah, of course we can. But to do that, we need to represent an actual wall with a minimum thickness. Here we have a 5-sided pyramid, and the bottom plane is not modeled because what we want to do is sort of make this an open, hollow cone shape. To do that, we would need an interior wall, and at Building 61, we tend to recommend that that wall thickness be at least 1/8 of an inch or 3 millimeters, and that's just based on the kind of machines that we have. Now, just like the cube, we need to represent a surface that connects those two walls, and that might look like this. So now we have an exterior wall, an interior wall, and also this cap in between those two walls, and those edges meet airtight. If we joined those together, what we would see is that now we've got one open shape that is ready to be 3D printed. Now let's talk about a challenge that is different for every type of 3D printing machine. All of these machines need to hold the part securely to the bed of the printer. That's where the first layers of the printer get started, and everything else is built on top of that, so they have to be successful. They have to be stable. Sometimes they're held up with these cool scaffold systems. Sometimes that scaffold system is broken away. Sometimes that scaffold system is actually dissolved in a little bath. It's pretty crazy, actually. But sometimes we need to set the print up for success by splitting parts that aren't stable on the bed. Imagine a sphere. It's printing one layer at a time on this bed, and that first layer is only touching the bed at a single point. Now, can it build a scaffold to hold the side walls up? Yes, it can. But another way that we can dramatically increase our chances of success is by doing something like this. We just split that shape. In this case, we have a split sphere. So instead of touching the plate at one point like this ball would, what we've done is we've turned that ball into 2 domes that have a broad surface area, lots of contact, high chances of success. And once they're done printing, we can take these 2 pieces and then join them back together to create, in this case, a sphere. All right, let's cover one more lesson with a slightly more complex object in this teacup. Now, let's also review everything that we've covered up to this point. Is this object represented on all sides? Well, looks like no. Let's fill in that bottom. Excellent. Does this object have a real wall thickness? Well, let's jump into this, what we call a ghost view. And if we look inside this, we can see indeed there is an interior wall and an exterior wall, and at least appear to have a thickness that a printer should be pretty happy with. Is it located flat and sturdy on the build plate? Definitely. It will definitely also print with some support here. I don't know if we can reorient it so that it wouldn't, but we've checked the first 3 boxes now. Last but not least, what happens if we select this? Odd, it doesn't select the handle, and vice versa. That's because I have tricked you. And if we zoom in to that space between the two, you'll see that there is a 5-lane Washington, D.C. level highway in there. Unacceptable. A printer will look at this as basically a part that's floating out in space. It will try and print it, but more often than not, it will turn into a mistake, and it certainly won't be connected to the cup. So let's connect it to the cup. I'm just going to slide it over here to where they intersect, select both parts, and join them together. Now what you see is we have an object that is represented on all sides. It has a real wall thickness. It is firmly planted on the base as it's oriented, and it is indeed one piece ready to 3D print. So let's take a quick look at what needs to happen to a 3D model in order to make that happen. We don't actually load a 3D model into a 3D printer. We upload a set of instructions we call G-code that's generated by a slicing software. A slicing software does kind of what it sounds like. It takes a model and turns it into layer by layer instructions for recreating your object in the printer. What you see here in blue is support material, and of course the teacup is in red. Once we've generated this file, we can save it, and that's what we load into the 3D printer. What software you choose for 3D modeling depends on a lot of things. The price, the brand of computer you use, or your general comfort with the look and feel. We recommend getting started with Tinkercad. It's free, it's browser-based, which means it works on any computer, and it only models in solids, which helps you avoid some beginner-level mistakes.
Thanks for watching. To learn more about 3D printing in general, be sure to check out our video, What is 3D Printing? Subscribe to our channel, and for more information about the space, check out building61.org.